Hi everyone, welcome to this episode of Keipert Labs. In this video today we're going to be talking through the concepts of distance, speed and time. Okay, so three things that hopefully you're quite familiar with by now, especially because many of you are already starting to get your L's or learning to drive. You'll be on your P's soon and you'll be out on Coffs Harbour's Road, so please, these are things that I want you to be aware of. But we're going to look at these from a physics perspective today. So thinking about what they mean, and how we kind of represent them, and because these three things are connected together in some of the calculations you're going to do. Okay, so I'm going to set up a table that we can start to fill in. Okay, so take a moment now to pause the video to draw up this table in your book before we keep going. Okay, so resuming the video now, we're going to start by looking at the property we call distance. Okay, now I would say distance. Well, then we're going to look at time, and then we're going to look at speed. Okay, so distance, we're trying to frame these in kind of everyday terms. So how far it is between 2 points, or if we're thinking more generically about objects and their motion, we might say how far an object travels. Okay, we give it the symbol of a lowercase letter d, and we measure, unit of measurement is meters. That is with an M. Okay, so time. Now, I mean, we're not trying to think of anything too abstract here. We're not getting into Einstein sort of territory. If you want that, ask Mr. Holmes. Okay, but here, so we're talking about time. So how long an object is travelling is how we're going to define it in this situation. Is travelling or has travelled, depending on whether we're caring about the past tense or not. Okay, we give time the symbol of t, and then the unit of measurement is seconds. Okay, now we might measure it in minutes, we might measure it in hours or days or years, so depending on exactly what we're trying to be measuring. But that, some measurement of time in whatever's appropriate in that situation. Okay, so now we get to speed. So we might say how fast an object is travelling. Okay, is kind of our more everyday sort of definition that we might use. And what we're going to say to upgrade that a little bit is how far an object, car, a person, a bullet, a satellite, or whatever, travels for every second it is travelling. Okay? So, how far an object travels, the distance it travels for every second that it is travelling. Okay, so we give it the symbol, often we give it the S. Okay? Now, and so then what we would then say its unit of measurement is meters per second. Okay, so we would say m/s, or ms to the -1 is another way that scientists might refer to it. Okay, what this is getting at here, mathematically it's exactly the same as this. Okay, because if we say, alright, if I just use a little bit of space over here. Now, you may or may not have gotten to this concept in maths yet, but this idea that anything to the power of -1 is the same as 1 over that thing. Okay? So, m times s to the -1 is the same as meters times 1 over seconds, which is the same as meters over seconds. Okay? It means the same thing. Okay, now the reason that we would do this is that in physics in particular, where sometimes we're having to combine units together for a particular number, it helps us to use this notation so that we don't have lots of slashes going everywhere in a way that can confuse us. Okay, so this helps to give us a little bit of extra clarity once you're kind of used to what that looks like. Okay, and so what we can see is that distance and time are related together by the property we call speed. Okay, and so I'll show you a little bit about how we can relate those two together now. Okay, so we said that an object's speed is related to how far it travels for every second that it is traveling. We said that, so that is, its distance divided by its time. So we said distance was measured in meters, time was measured in seconds, so therefore speed is measured in meters for every second that it's traveling. Okay, so if I said that its speed was 40 meters for every 1 second, that means in 1 second it travels, you guessed it, 40 meters. Over 2 seconds, it's 2 times 40 equals 80 meters. Okay, so for every second it's traveled 40. If it's traveled 2 seconds, it's doubled that, so 80 meters, and so on. Okay, so what we can then do is then we can say, all right, well, we've got speed equals distance over time. I could then rearrange that into two other versions depending on what we might be trying to calculate. Okay, so I could say, all right, I want distance to be the subject. Distance equals, and I'm going to say speed multiplied by time. Okay, so that'd be distance in meters, speed in meters per second, and time in seconds. Or I could make time the subject, which equals, so time, that would be in seconds, is equal to distance in meters divided by the speed in meters per second. Okay, so I've got three maths equations here. Three versions of the same thing, I should say. Okay, so let's say I've got version number 1 in the blue bubble, version number 2 in the fetching green bubble, and version 3 in the nice red bubble over here. So they're all variations on exactly the same formula, but just have different things being the thing that's on the left hand side: speed, distance, and time. The reason we would do this, and the reason how we would decide which one to use, depends on which is the thing that we don't know and which are the two things that we do know. Okay, so if you know distance and time, then this is the formula that you would use. If you know distance and speed but not time, then you'd use number 3. If you know speed and time but not distance, you'd use number 2. Okay, so make sure that you write those formulas down and you keep them close to hand. Okay, and not using very complicated algebra to turn one thing into another, but I know that we're still developing that skill and developing confidence with that for the most of us. So keep those handy so you can decide which formula you need to use as you work through the next exercises. Okay, thanks for watching. Bye for now.